Hello everyone and welcome back to our discussion about the six trigonometric ratios. In here, we're just going to have a practice video about what we have discussed previously, which is actually the relation of the unit circle, which is this one, if you remember, with its to its trigonometric ratios, which is sine, cosine, tangent, and its reciprocals such as cosecant, secant, and so on and so forth. Now, let's have some uh, practice problems here. Let's start first with this one, true or false. Number one, non-adjacent side is just the same, or sorry, it's not the same as the opposite side. Well, the answer for this one is actually false. All right, this is false. Wait, all right, this is false. Why? So you see, if we have a right triangle here, and let's assume that we have an acute angle here. If a side that is beside with this acute angle, or a side that is beside with this one, to be particular, it's a leg. If there is a leg that is beside with this angle, acute angle to be particular, that side would be your adjacent or ADJ in short. This one, on the other hand, which is not beside to this one, that will be what? Opposite side. Or, in other words, this is your non-adjacent side. So the answer is false. They are just the same, synonymous, basically, right? So, number two, we are going to label a side of a right triangle as adjacent side if it is not beside to a given acute angle. I already mentioned this one earlier, so this is false. All right, this is false. Why false? Because you see here, we're going to label besides adjacent if and only if it is beside with this angle. All right, since this angle is beside with this leg, therefore that leg would be your adjacent side. All right, that's why it's called adjacent, because this leg is adjacent to that angle, or in other words, it's beside with the angle. All right. So next, number three. In the unit circle, your x is equal to sine theta and your y is equal to cosine theta. The answer here is false. All right, false. Remember that your x here, what should I write? Your x here is equal to cosine theta. Remember that. Your y, on the other hand, will be your sine theta. Okay? So x cosine, y sine theta. Now, number four, in the unit circle, we can find the horizontal component and the vertical component of the radius with the use of sine theta and cosine theta as long as there is a given acute angle. The answer here is 2. Okay, read this one very carefully. In the unit circle, we can find the horizontal component, the vertical component of the radius with the use of sine theta and cosine theta as long as there is a given acute angle. Yes. So let's use this one. Like the last time that we discussed about the relation of the unit circle and the trigonometric ratio. Let's just say I will use light blue here. Wait, wait. Right, there we go. So let's just say this is your unit circle. I mean, of course, this is a unit circle. Then let's just say that you have a terminal side and it rotates 60 degrees counterclockwise. So it stops until here, right? This is your terminal side. And here, this is still your radius. Because remember, in the radius or the radius of a circle, whatever would be a line segment that is between the center and to an endpoint, that is your radius. So this one, oh wait, I think I have to use darker color because I'm actually having a hard time. So, so again, so this is your what? Your terminal sides. And in this case, this is also your radius. Why? Because you see, why is it gone though? Okay. Because you see, in any line segment, if we are talking about a line segment between the center and the endpoint or given endpoint to be particular, that is your radius. So this is your center and it connects here. I mean, it its distance is going to this given endpoint. So this is your radius. So we can get the component of this radius. First and foremost, right? It rotates from here going there 60 degrees, right? You can see it here, 60 degrees. So that means if I'm going to let me erase this one. If I'm going to visualize it, it looks like this. Okay, it looks like this one. So you have 60 degrees. So we can get its horizontal component. So we have this one, okay, your x component or the horizontal component, and we can get its vertical component, which is this one. Okay, by how though? All you need to do is use the trigonometric functions. So for x, you can find the horizontal component of your radius by the use of cosine theta. For the y, on the other hand, you will use sine theta. Okay? As long as there is a given acute angle, which is 60 degrees. So with this one, we can find our x. So x is equal to cosine 60 degrees. Then we have here, what do you call this one? Y is equal to sine of 60 degrees. Yes. So there we go. We can now find our x value. Remember that cosine 60 degrees, it's 1/2. And sine 60 degrees is square root of 3 all over 2. And there we go. We can find its sides. To be particular, its components, right? As long as there is a given acute angle. All right, we can do that. Now let's solve for this one. So what is sine 30 degrees? So here, remember the hand technique that I taught you, which is basically the most useful technique, in my opinion, because instead of just memorizing this list, the list here, right, this one, all you need to do is just use this one, right, this technique. So let's use sine 30. So remember how to do sine 30, okay, by using your left hand technique. So you see my hand right here, you see that? So remember that this is 0 degree, 30 degree, 40 degrees, 60 degrees, and 90 degrees. All right. So if you're going to find sine of something, you have to count 0 up to 4. So 0, 1, 2, 3, 4. You're going to stop at what degree you're looking for. So this is 30 degrees. So I'll stop here. So 0, 1. Okay, 1. So if I have 1, what will I do? I will square root it. So the square root of 1 is 1. Then after that, in your palm right here, you have a what? A fraction or a denominator of 2, which is this one. Hold on. Which is this one. All right? So that means if you have square root of 1, then your answer would be 1 all over 2. All right, so that is sine 30 degrees. If you have, if let's just say you want to have more detailed information about this one, I suggest you should watch the previous video that I recently discussed. All right, so let's go. Next is we have sine of 135 degrees. So here, we cannot just simply use the hand technique here because that one, that angle or this angle, I mean, it's beyond 90 degrees and it's not within the range of 0 degrees to 90 degrees. So what are you going to do? You will do reference angle, right? So what is the reference angle of 135 degrees? So first and foremost, where does 135 degrees located? Where is it located? So if the angle given is greater than 90 degrees, but less than 180 degrees, then that means it is in the second quadrant. Okay? And if it's in the second quadrant, your ordered pair would be negative and positive. Okay? Negative and positive. So meaning your x value is negative, your y value is positive. Okay. So how to get now your what's that? How to get now your yeah, reference angle. If the given angle is within, or rather it is in the second quadrant, what you're just going to do is you're going to subtract 180 degrees by that given angle. If and only if it is in the second quadrant and the angle is positive. All right? Remember that. Okay? So let me tell you again. So if the angle is positive and it's located to the second quadrant, you will use this one to get the reference angle. So here we have 135 degrees, right? So 180 degrees minus 135 degrees. So this is 45 degrees. So this is just the same as sine 45 degrees. But, okay, as you can see here, oh wait, no. Yeah, as you can see here, the ordered pair here is your x is negative and your y is positive. So if your x is negative, that means you have, wait, if your x is negative, that means you have negative cosine. But since your y is positive, so that means you will have positive sine theta. So therefore, sine 135 degrees is just equivalent to sine 45 degrees. So that's it. Now, what is sine 45 degrees? So let's go here, all right? So in your left hand, so once again, you're looking for the sine, so you will count from 0 up to 4, all right? But of course, you're going to stop at a certain angle that you're looking for. So it's sine 45 degrees, so you stop at 45 degrees. 0, 1, 2. This is your 45 degrees. So you have your 2 here, so you're going to square root it. So you will have what? You will have square root of 2. Then, don't forget, in your palm, you have divided by 2, all over 2, basically. So you have square root of 2 all over 2 as your answer. All right? So we're good to go. So let me just erase the handwritings. Wait, let me just erase this one. Oh, for a while, guys. You know what? Let me just use my eraser. Okay, so how about for the third one, which is cosine 240 degrees? Okay, so this one is just similar as the previous problem we solved. All right, it's beyond 90 degrees. So what are we going to do? So first and foremost, locate where 240 degrees is. So you see 240 degrees is actually in the third quadrant. How would you know if the angle is in a third quadrant? If the angle is greater than 180 degrees, but less than 270 degrees, therefore it is in the third quadrant. All right? And another thing here is that in the third quadrant, your ordered pair is negative and negative. So that means your x here is negative, your y is also negative. So how to get the reference angle? So here, if you have a given angle, which is 240 degrees, and it's actually in the third quadrant, now you're going to subtract it by 180. So 240 degrees minus 180 degrees. Okay? So again, you'll only do this one if and only if the angle is within third quadrant. And of course, don't forget if it's positive. All right? So I forgot to mention that. First, take a look at the angle. Is it positive or negative? Positive. Second, uh, where is it located? Third quadrant. Now, if it's third quadrant, now, what will be your given angle? You're going to subtract it by 180, which is this one. And remember that your ordered pair You have two coordinates that are both negative. So let's get the answer here. So 240 minus 180, 240 minus 180. I think this is 60 degrees, right? Am I right? 60 degrees. 18, 19, 20, 21, 22, 23. Yeah, 60 degrees. Okay. So cosine, let me just write it here. Wait, let me just rewrite the other answers here because I have no space. So yeah, going back, cosine of 240 degrees. So it's just equivalent to cosine 60 degrees. But wait, we're not done yet. Let's take a look. According here, your x and your y are both negative. So therefore, you will have negative x. And with that, you will also have negative cosine theta. So in other words, if your x is negative, you will have negative cosine 60 degrees as well. Right? You will have negative cosine 60 degrees as well. If x is negative, your cosine is negative. That's it. So what is cosine 60 degrees? So remember in your, what's that again? In your left hand, which is this one, all right? If you see me here, in your left hand, so if it's first the sign, you're going to count from 0 up to here, which is 0 to 4. Cosine, on the other hand, you will do it opposite. So you'll start counting 0 here up to 4. Remember, the angles, the position of the angles here do not change. So that means this is 0 degree, 30 degree, 45 degree, 60, and 90 degrees. All right? Remember that. So let's count. 0, 1. This is 60 degrees. So square root it, you will have 1. Divided by 2, it's 1 half. So we have negative 1 half. And that is our answer. Cosine 240 degrees is negative 1 half. All right? It's negative 1 half. All right? Let me just erase this one. Okay. No space. Oh my God. But at least you guys listen. That's all that matters. Because if you don't, then you will not understand what I'm doing right now. We're halfway there. We have sine of negative 330 degrees. Okay, so this one, you might be having a hard time because it's negative. So you can either do reference angle, then after that, you can get the answer. All right? As long as you know its location, then we're good to go. Right? Because in reference angle, right, you need to know the location, right? Or what you can do is you can do coterminal angles, find the coterminal angles of this one, then you do reference angle. So let's try to do both, okay? So that you will have the idea. What if I'll get the reference angle of negative 330 degrees? Is it possible? Yes, it's still possible. I actually discussed this one on how to get the reference angle if uh, you have an angle that is negative, all right? And the range is within negative 360 degrees up to 0 degrees. Okay? So it's actually within the range. Okay. Where is negative 330 degrees located? It's actually on the first quadrant. Because if you're going to graph it this way, if your quadrantal angles, or let's just say the angles, or much better, the angle is this range from negative 360 degrees to 0 degrees, then you will have this one. 0 degrees, negative 90 degrees, negative 270 degrees, negative, no, 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 it's not 270, it's actually 180 degrees. Then negative 270 degrees and negative 360 degrees. All right? So if you're going to do that, I mean, if you're going to have this angle, so you're going to rotate clockwise. So where is negative 330 degrees? It's actually within the first quadrant. So from here going there, right? You will have this one. Wait, you will have this one. All right, so this is negative 330 degrees. So what you're going to do here is you're going to find the what? The reference angle. So by how? If your angle is negative, number 2, it's located on the first quadrant. Then what you're going to do is you're going to add 360 degrees by that given angle. Okay? Add 360 degrees by that given angle. So we have a given angle of negative 330 degrees, right? So you will have 360 degrees plus negative 330 degrees. So this one is just the same as subtracting 360 degrees by 330 degrees. So this is 30 degrees. Okay, so it's 30 degrees. Now, okay, now that you have found your reference angle of negative 330 degrees, so with that, we can now say that sine negative 330 degrees is just equivalent to sine 30 degrees. But wait, we're not done yet. Okay, we have to make sure it's ordered pairs. So in the first quadrant, the ordered pair, I mean the coordinates of the ordered pairs are both positive. So meaning your x and y are positive. Since your y is equal to sine theta, therefore, if your y is positive, then your sine theta is positive as well. So it is positive sine 30 degrees. So what is sine 30 degrees? Okay, so use your left hand. Okay, so again for sine, count from here up to here from 0 to 4. But of course, you're going to stop at the given angle you're looking for. So 0, 1. 30 degrees is here, so stop right there. Now square root it, you will have 1 divided by 2, 1 half. So therefore, sine of negative 330 degrees is just 1 half. That's it, right? The answer here is 1 half. You know what? I'm gonna erase all the answers here. Okay, what you're just going to do, just pass backward, okay? Because I have no space here. Forgive me if I couldn't write it here, right? But don't worry, as long as you're listening, you'll get my points, right? So we're good to go. Or we can do the other way, which is getting the coterminal angle. So if you're going to get the coterminal angle of negative 330 degrees, make sure it is within the range of 0 degree to 360 degrees. It's within this range, okay? It's within that range, okay? So since negative 330 degrees is beyond this interval, so we're going to add 360 degrees, right? So that we can uh, at least expect that the angle that we're going to add with 360 degrees will be within this interval. So negative 330 degrees plus 360 degrees, the answer is 30 degrees. So it's 30 degrees within this location. The answer is yes, because it is between 0 degree to 360 degrees. So yes, it is located within that interval. Because of that, we can say that sine of negative 330 degrees is just the same as sine 30 degrees. And what is sine 30 degrees? I already told you it's 1 half. That's it. There we go. So now let's proceed to the number 5. Tangent 360 degrees. What is tangent again? Tangent, remember, tangent theta is just the same as y all over x. Or it's just the same as sine theta all over cosine theta. Okay? So therefore, if we have tangent of 360 degrees, you will have sine 360 degrees all over cosine of 360 degrees. But you see, you don't know what's 360 degrees. All right? Maybe you could use your left hand rule. We can do that actually. We can. Right? We can actually do that by getting the reference angle. But you see, a reference angle, it's an acute angle, right? So what I'm trying to point out here is that uh, wait, you know what? Let me just draw it for you. Where is 360 degrees located? It's actually here, right? It's just beside with 0 degrees, right? So here, you can use reference angle, but you know, for a reference angle, it should be an acute angle. All right. So if you're going to do that, you're going to have a result of 0 degrees. All right, because if your angle is located like within that axis or x-axis, I don't think that you could use reference angle, but uh, no, actually you could, but again, reference angle is an acute angle. So what you're just going to do, just use coterminal angles. Or, much better, you should be familiar that if you have 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees, I always familiar that they are just a mirror to each other, but the signs are negative. Like for example, 0 degree is just a mirror to 180 degree. 0 degrees, remember that you will have 1 and 0. 180, numerically speaking, you have 1, 0. But if you're on this side, remember that your x value here is negative. Okay? All right? In the second quadrant, your x value is negative. And on the third quadrant, your x value is also negative. So therefore, your 1 is negative. So they are just a mirror to each other. Therefore, 360 degrees is just also like a mirror to 180 degrees. 90 degrees as well, you have 0, 1. It's also a mirror to 270 degrees, which is 0, then 1, numerically speaking. But you see, 270 degrees is below the x-axis. So meaning your y value here is negative. All right. So therefore, you have negative 1. Right. So they are just a mirror. So learn how to learn how to be familiar with this one. Okay. Because you would be having a hard time if you're going to use reference angle, and hence you will be confused. So just be familiar with this one. But what if it's greater than 360? Then do coterminal angles, right? So with that, we can now proceed in here. Sine 360 degrees is just equivalent to 0 degrees, right? They're just the same. So what is sine 360 degrees? Remember that your sine is your y, your x is your cosine. So since here, your y here is 0, therefore sine 360 degrees is also 0. All over cosine 360 degrees. So since here, your x here is 1, therefore your cosine 360 degrees is 1. Hence, tangent of 360 degrees is 0. That's it. We're good to go. All right? So now next we have 3 more problems. The secant, cosecant, and cotangent. All right, let me just erase this one. Wait, hold on. Wait. Okay. So here, secant 450 degrees. Remember that secant theta is just the reciprocal of cosine theta. So it's 1 all over cosine theta. That's it. Okay? Secant is the reciprocal of cosine theta. So secant is equal to 1 all over cosine. So we have secant of 450 degrees. All right? So meaning it is just the same as 1 all over cosine of 450 degrees. So what is cosine 450 degrees? You see this one, it's beyond 360 degrees. So what are you going to do? Find the coterminal angle of 450 degrees within the range of 0 degree to 360 degrees. Okay? Find it within here. So with that, okay, since 450 degrees is beyond this interval, what we're going to do is we're going to subtract it because this one is greater than 360 degrees. So 450 degrees minus 360 degrees. So 450 minus 360 degrees is 90 degrees. So meaning secant 45 degrees is just the same as secant 450 degrees is just the same as secant of 90 degrees. And because we have secant of 90 degrees, we will have 1 all over cosine of 90 degrees. So what is cosine of 90 degrees? Count. 0. We're going to stop right there. Why? Because this is 90 degree. So 0, square root it, it's 0. Oh, okay. Sorry, I had actually a timer. So we're going to finish this one as quick as we can. So yeah, cosine 90 degrees here. So 0, square root it, it's still 0. Divided by 2, it's 0. So we have 1 all over 0. So here, you cannot divide any number by 0. So 1 divided by 0 or 1 all over 0 is wrong. Hence, this is undefined. All right? So the answer for secant of 90 degrees is undefined. All right? It's undefined. Okay? So next, we have last two problems. So we are asked to find cosecant 450 degrees. So cosecant 450 degrees. Remember that cosecant theta is just the reciprocal of sine theta. So it is 1 all over sine theta. Cosecant theta is equal to sine theta. And because of that, we can say that cosecant of 405 degrees is just the same as 1 all over, sine of 405 degrees. Now, here's the thing. It is not actually, I mean, I'm pertaining to the angle, okay? I'm pertaining to the angle. The angle is not within the interval of 0 degrees to 360 degrees. I mean, within the interval of 0 degrees and 360 degrees. All right? So with that, we're going to find the coterminal angle of 405 degrees within this interval. So since 405 degrees is greater than 360 degrees, so what you're going to do, you're going to subtract it by 360 degrees. So 405 degrees minus 360 degrees. I do believe this is, wait, let me just try to subtract it manually. This is just the same as negative, oh wait, no. It's just the same as 400 degrees plus 5 degrees minus 300 degrees minus 60 degrees. So if I'm going to combine uh, 400 and negative 300, so I will have 100 degrees. This one, 5 degrees minus 360 degrees, I will have negative 55 degrees. And with that, I will have 45 degrees. So yeah, the answer here is 45 degrees. 45 degrees. So with that, we can say that cosecant of 405 degrees is just the same as cosecant of 45 degrees. And due to that, we can have sine of 45 degrees. So what is sine 45 degrees? So use your left hand technique. 0, 1, 2. 45 degrees is here, so we're going to stop right there. So we have 2. Square root it, square root of 2. Divided by 2, it's square root of 2 all over 2. Then we can simplify this one. This is 2 all over square root of 2. Okay? If you're curious of how I did that, it's like this. Right? We have 1 all over square root of 2 all over 2. 1 is just the same as 1 all over 1. This is actually based either from the identity property equality of multiplication or identity property equality of division. All right? Because you see, A is just the same as A all over 1. So meaning, any term can have an invisible denominator of 1. So we have that one. So now, if you're going to simplify this one, what you're going to do is, if you're going to find the numerator, you will multiply the outside. So you have 1 and 2. So 1 times 2 is 2. Then to get your numerator, you will multiply the inside. So 1 times square root of 2, it's 2 square root of, wait. There you go. It's 2 all over square root of 2. And we can simplify this one because in simplifying a fraction that has a radical term on the denominator, we can uh, we can put the radical term above. All right, by how? By rationalization, or in other words, you will multiply both sides of the fraction by your denominator. So you will have 2 times square root of 2 all over square root of 2 times square root of 2. 2 times square root of 2 is just square root 2 times, oh wait, 2 times square root of 2 is just 2 square root of 2. And square root of 2 times square root of 2 is just 2. And we have 2 on both sides. So 2 divided by 2 is square root of 2. Hence, cosecant 400 and, 400, here we go again. Cosecant 450 degrees is equal to the square root of 2. That's it. Okay, so now we have our last problem, which is cosine of 495 degrees. Right? Let me just erase this one. Wait, hold on. Let me just erase this one. Cosecant, wait. Cotangent of 495 degrees. Wait, for a while. So, remember that cotangent theta is basically the reciprocal of tangent theta. So, cotangent theta is equal to 1 all over tangent theta. Or, we can have cosine theta all over sine theta. Okay? How did I get that? Well, remember that tangent theta is equal to sine all over cosine, right? So we have 1 all over sine theta all over cosine theta. And remember what I did, like, to the fraction earlier? Wait. Remember what I did in the fraction earlier? Which is 1 all over square root of 2 all over 2. Do the same thing here and you will get the result. Cosine of theta all over sine of theta. Okay? So what are we going to do now? So we will use this one because this one is much more simple. So cotangent of 495 degrees, oh wait, is just the same as cosine of 495 degrees all over sine of 495 degrees. But you see, this one, this one is not within the range of 0 degrees and 360 degrees, just like the other previous problems we solved. So therefore, we're going to find the coterminal angle of 495 degrees within this range. So since 495 degrees is greater than 360 degrees, so we will subtract 495 degrees by 360 degrees. All right. So I'll do the same technique here. So this is just the same as 400 plus 95 degrees minus 300 degrees minus 60 degrees. So if I'm going to combine 400 and negative 300 degrees, is just 100 degrees. This one, 95 minus 60, this would be plus 35 degrees. Right? It's plus 35 degrees. So you will have 135 degrees. So okay. So 145 degrees is just equivalent to 135 degrees. Okay? They are equivalent to each other. So with that, we can simply rewrite this cosecant, here we go again, cotangent as cotangent of 135 degrees is equal to cosine of 135 degrees all over sine of 135 degrees. So how to find the value of this one? How would you do that? So you will use reference angle. All right? Where is 135 degrees located? Let me erase this one. All right? Since we're done recalling this one. So where is 135 degrees located? So it's actually on the second quadrant. So first and foremost, the angle is positive. Okay? It's positive. Second, it's located at the second quadrant. All right? How would you know again if the angle is located at the second quadrant? If the angle is positive, all right, or in other words, it rotates in counterclockwise, and the angle is between, or rather, it's greater than 90 degrees, but less than 180 degrees, That means your angle is at the second quadrant. Okay? So now what are we going to do? So here, you will subtract 180 degrees by your given angle. Right? And do not forget that the ordered pair in the second quadrant has the coordinates of a negative x value and a positive y value. So negative x and positive y. So you have a given angle of 135 degrees, right? So 180 degrees minus 135 degrees. This is just 45 degrees. Hence, cosine of 135 degrees is just equivalent to cosine of 45 degrees all over sine of 45 degrees as well. But we're not done yet because remember, we have an ordered pair here for the second quadrant. X is negative, y is positive. Since your x is negative, therefore your cosine is negative. Since your y is positive, so we will let it be because it's already positive. So negative cosine 45 degrees. So use your hand. So here, so we have 0, 1, 2. This is 45 degrees. You're going to stop right there. So square root of 2, it's square root of 2. Divided by 2, you will have square root of 2 all over 2. So negative square root of 2 all over 2. Now, how about for sine 45 degrees? So you count from here. 0, 1, 2. This is 45 degrees. So stop right there. Square root it, you will have square root of 2. Divided by 2, you will have square root of 2 all over 2. So here, if you're going to divide them, your answer would be negative 1. All right? Because you see, you have the same value, numerically speaking. Wait, there we go. So you have the same value, numerically speaking, square root of 2 all over 2 above and below. But you see, on the numerator, we have a negative sign. So that means if you're going to divide both sides, if you're going to divide the numerator by the denominator, but the numerator is negative, despite that they're the same, the answer is negative 1. All right? So cotangent of 495 degrees is negative 1. And that will be all, guys. So, uh, yeah, so now that we're done here, let's continue our discussion soon about this one. All right? Because we discussed about having an angle that is a special angle, like 495 degrees, 135, 30, and so on and so forth. But what if the angle is not actually a special angle? We will discuss that soon. And see you soon.